So let's start. I am writing here one question by which we can understand the concept easily. So I am writing here 2-hydroxy butanal. 2-hydroxy butanal. It is the question or the IPSC name for which we need to draw the structure. So by noticing a question, we should decide the maximum number of carbon present in an organic compound by choosing express the total number of carbon. So but express 4 number, the word root but. So I am writing first 4 carbon. So first you need to choose the word root which express the carbon or the maximum word root which express the carbon. Maximum is principal or the longest means 4 carbons are present. Here 4 carbons are present by which, due to which but word root is used. In this case 4 carbons are represented here, and now we should decide the suffix, and the suffix will represent the organic compound's functional group. That means here the suffix which is present with the longest continuous carbon chain is Al. In this case, as the concept says, Al suffix represent the functional group, that is aldehyde. So aldehyde is a monovalent functional group and it always occupy the terminal end of a hydrocarbon chain or longest continuous carbon chain in case of open chain organic compound. So the aldehyde functional group which is CHO can be present in any end. That means this chain has 2 ends, that is this may be the end or this may be the end. In this case the aldehyde functional group can be present at this side or this side. I am expressing the functional group of aldehyde in this side. So as the compound, the given IPC name of the organic compound includes the carbon atom of the functional group. After choosing the functional group, now we should do numbering of the chain. That means I am doing numbering of the chain which express there is 4 number of carbon, and at the number 2 position or the locant 2, the hydroxy group is present which is the junior functional group. Groups are expressed using their IPC name, and the junior functional group are expressed by using their prefix. In this case, the prefix for the junior functional group is hydroxy. Hydroxy prefix express the functional group, that is alcohol. So alcohol is also a monovalent functional group, but it does not carry any carbon atom as it is located at the locant 2 position. So I am placing OH group directly bonded to the carbon atom of which has the locant 2. After that there is no substituents. So now I need to satisfy the valency of all carbon by placing hydrogen. In this case, this carbon is bonded with 3 single covalent bonds. So it will occupy single hydrogen atom. In this case 2 bonds are present, so it will possess 2 hydrogen. In this case it is a terminal carbon and it contains only single bond, so it will express by 3 hydrogen to satisfy the valency of carbon. It is the real structure of the given IPC name. In this way, you can draw the structure of an organic compound by the previous idea upon the IPSC name. So, let's press. So, write the question first. Methyl 3-chloro hexanoic acid. Hexanoic acid. 2-methyl 3-chloro hexanoic acid. First you try to answer the question. After that, I will give you the answer. You should try for 30 seconds. So, from this question, everyone should notice that there are two word roots which express the carbon atom number. That means, in this case, two roots are and meth express single carbon atom. So, from this concept, I have told that the maximum number of carbon express the parent chain, that means the longest continuous carbon chain. In this case, hex contains the parent chain, that means 6 carbon is the parent carbon chain. So, I am writing first 6 carbon by placing single bond between the carbon atoms. So, I am writing 6 carbons here. After writing 6 carbon, now I am placed the numbering and to progress the numbering from one end to another end. So I have numbered the carbon, and from this part we can show that 6 carbons are present in the organic compound. After that, one can go from substitution side to main functional group side, or from main functional group side to substitution group side. That means here the main functional group is COOH. That means oic acid always express the suffix of carboxylic acid. So I have written here carboxylic acid functional group, that means COOH. In this case, the 2 position and 3 position, that means the second carbon and third carbon are occupied by the methyl group. So methyl is an alkyl group, or methyl is an alkyl group. So meth express 1 carbon. So after putting the n value 1 in alkyl group, we can find the value of alkyl group, that means CH3, and 3 position occupied by the carbon atom, chlorine atom, that means the halogen. So after that, we have completed the functional group part, substitution group parts. So now we need to satisfy the valency of all the carbons present in the longest continuous carbon chain. That means now I am placing here hydrogen to satisfy the valency of the carbon atoms present in the longest continuous carbon chain, which is the actual structure of the given IPSC name. In this way, anyone. Let's solve couple of questions. First you should try, then I will answer to your question. So I am writing 4 nitro 3 bromo heptanal. First you should try, after that I will answer. 4 nitro 3 bromo heptanol. First we need to find out the word root for carbon. That means here the word root for carbon is only one word root for carbon is present, because nitro express the nitro functional group or nitro alkanes functional group, bromo express or bromo comes under the functional group, that means haloalkane, and here hept only the word root which express the carbon number. So carbon number for hept is 7. So 7 carbon gets expressed by the word root, that is hept or sept. So here 7 carbon are present. After placing 7 carbon, I will go for the substitution group parts. So first we need to place 7 carbons. So now we have placed 7 carbons by using the single bond or sigma bond. In this case, the functional group is aldehyde. So here the aldehyde functional group should occupy the number 1 position. So I am placing the number 1 position from this side, that means C double bond O single bond H. C double bond O single bond H means CHO. It is the actual functional group for aldehyde. It is the open structure of aldehyde, and I am numbering the carbon chain from the carbon atom of the functional group. So I am putting here number 1 position. I am going for rest of the carbons. Now the carbon 4 and the carbon 3 occupies the substitution group or occupied by the substitution group. That means here the 4th carbon possesses the nitro alkanes functional group, that means NO2 functional group. Now and the 3rd carbon functional group section and the junior functional group section in this carbon chain. In this case, this carbon occupies 2 hydrogen, IUPAC name. Two identical methyl groups, and the two types of word root are present here, meth and hex. So from the word root I have told that the maximum carbon atom expressing word root express the parent chain in an organic compound. So here hex is the word root which express 6 number of carbon atom present in an organic compound. So I am placing 6 number of carbons by putting sigma bond between them. So here I am placing 6 number of carbon atom and sigma bond placed between the carbons. I am numbering now. So here the name does not obey the rule, but I am drawing the structure of the given IUPAC name. But the rule says, okay, the second carbon contains 2 identical substitution groups. Here the identical substitution groups are methyl group. So CH3 and CH3 are present directly bonded to the second carbon, and the hexanamine means 6 carbon are present, and amine is present at the 3rd carbon. At the 3rd carbon, or to the directly bonded to the 3rd carbon atom. That means amine has the functional group, that is NH2, which is present directly bonded to the 3rd carbon atom. So now we have completed. That means we need to satisfy the valency of the rest carbon in the longest continuous carbon chain section. So satisfy the valency of the carbon atoms. It is the real structure of the given IUPAC. We can move to practice some different question from this section. 2 chloro, 3 hydroxy, 2 chloro, 3 hydroxy, heptanoic acid. So also I am placing some more substitution groups, 2 chloro, 3 hydroxy, 4 diethyl, 4 diethyl heptanoic acid. In this case, first you should try the answer, that means structure of the organic compound from the given IUPAC name. After that, I will give you the correct sequence to answer the question. First you should try. Chloro express the functional of chlorine. Carbon word root. Here di term, I have told di express the numerical term or the identical substitution of carbon is present in this part. So it is the parent chain of this given IUPAC name. So hept is the total number of carbon present in the longest continuous carbon chain. So in this case, I am placing 7 carbon by using the single bond. So I am numbering the carbon chain. Now we should decide the functional. So in this case, the main functional group is carboxylic acid. Why it is the main functional group? Because it is present with the parent chain. Why it is a parent chain? It is a parent chain because it contains maximum word present in an organic compound. So here hept express the maximum number of carbon. So it is the parent chain, and the parent chain contains the suffix for carboxylic acid. So it is the principal functional group or the senior functional group for the given IUPAC name. So the number 1 position is occupied by the functional group part, which gets occupied by the functional group of carboxylic acid. In this case, the second carbon occupies the functional group of chlorine, and the third carbon occupies the functional group of alcohol, because hydroxy is the prefix for the functional group of alcohol, that is OH, is occupied by the alkyl group, that means 2 identical alkyl group. So 4 position occupied by the 2 identical alkyl group means ethyl group. So ethyl group has the formula C2H5. How C2H5? I have told in the previous classes that alkyl group has the formula CnH2n. Each word root express 2 number of carbon present in an organic compound. So if I will place here 2, the value of the total alkyl group or the value of carbon and present in put the ethyl valency of carbon atom present in the organic compound of given IUPAC name. So this carbon is bonded with, so it will occupy bonded to 4 different types of carbon. So it will occupy no hydrogen because it has satisfied valency. Now here will be 2 hydrogens will be present due to 2 single bonds have satisfied the valency of the carbon. Similarly, here 2 hydrogens will be placed, and here 3 hydrogens will be placed to satisfy the valency of the given organic compound. It is the real structure for the given IPSC name. From these concepts, you can conclude that how to draw the structure of an organic compound hexene, 2-methyl hexene. So, first I have taken simple example. In the previous questions, we have taken the alkane, but in this case, we have taken alkene. So, alkene has the formula CnH2n. CnH2n. So, hexene has the formula. Hexene has the formula CnH. From CnH2n formula, we can put here C6 means S will be 12 for hexene. But the second carbon, from second carbon, one hydrogen gets displaced or replaced, and which is occupied by the alkyl group. Alkyl group is methyl. Opening the structure, that means here 6 carbon is present. So I am expanding the carbon by placing single bond between the carbon. So here I have expanded the structure 6 carbon. I am numbering the carbon chain. From this, we can conclude if En is present, so it should have the number. If there is no number, then it occupy the number between carbon and hydrogen. And between the first carbon bond in the bit in between the first carbon and second. From this, it will possess 2 hydrogen and it will possess 3 hydrogen. From this, and I will give you question from the alkane section now. Three chloro, or I am writing here 4 chloro. 4 chloro, 4 chloro, 2 pentene. What I have written? 4 chloro is the first you should try. 4 chloro, 2 pentene. Four chloro, 2 pentene. What I have told in the previous question, if there is number or locant for or before the double bond position or before alkane, you should remember the double bond is present from that carbon or from that locant that express the carbon number and the next carbon. That means here the double bond is present between second carbon and the next carbon, that means third carbon. If double bond is present between second and third carbon, then the number 2 or the minimum position of the double bond is used to express the double bond. That means here 2 position express that second and third carbon are bonded by the double bond. If the double bond is present between 7 and 8 carbon, then it will be expressed by the locant 7, which will express that double bond is present between 7 and 8 carbon. So I am writing here pent means 5 carbon. So here 5 carbon is present. Here 5 carbon is present. I am numbering the carbons and placing the substituent group, that is chlorine, at the 4th position, and I have told 2 position express the position of double bond, that 2 and 3 carbon are bonded by double bond. So After that, we will satisfy the valency here 2 and 3. 2 and 3 means here 1 hydrogen will be present, 3 hydrogen will be present in this case. In this case, 1 hydrogen will be present, and in this case, 1 carbon will occupy 3 hydrogen atoms. So it is the actual structure of the given IUPAC name. In this way, anyone can write the actual structure of an organic compound from the given IUPAC name. So if you have any doubt in this lecture, comment in the comment section. I will clarify your doubts by making videos. Thank you.